Today we're going to learn about graphing systems of equations. A system of equations is two equations that you can graph on a coordinate plane, and they'll cross each other at one point, and that one point is your solution. Okay, so let's do an example or two. All of the problems that you're going to see today are going to be in the form y equals mx plus b. So yesterday we had to solve for y, we had to get them in this form, but today they're all going to be already in the form y equals mx plus b. So you don't have to get the y by itself, you just have to graph it. Okay, so let's look at the first line. The y-intercept is 4. Okay, so I'm going to go to the y-axis and put a dot on the 4. And the slope is 3 over 2. So that means I'm going to go 3 on the y-axis and 2 to the right on the x-axis. Now that's way off our graph, and so remember that 3 over 2 is the same as negative 3 over negative 2. So I'm also going to go backwards. I'm going to go down 3 and to the left 2, and down 3 and to the left 2. For systems of equations, we don't know where our lines are going to cross. So normally we just draw two dots and then we connect them with a line. But when we do systems of equations, we want to make sure that we are exact. So we need to keep counting the slope from dot to dot until our line goes all the way across the graph, so that we know exactly where the other line is going to cross. If we just drew these 2 points and drew a line, our line probably wouldn't be very exact, and then we might have a hard time finding exactly where the lines were going to cross. Okay, so we graphed our first line. Then here's our second line. The y-intercept is negative 3, so on the y-axis we put a dot on negative 3. And the slope is negative 1 over 4. And remember, we can write that as negative 1 over positive 4, or we can write it as 1 over negative 4. Those are both the same thing. So I can go down 1 and to the right 4, or I can go up 1 and to the left 4. Okay, so you see how I extended my first line all the way down here, and it's a good thing that I did because that's exactly where they cross. And if my line wasn't exact, I probably wouldn't get the correct answer. So now I need to write down the place where they cross using a coordinate pair. So remember, when we write a coordinate pair, we write it in parentheses, and we always write the x coordinate and then the y coordinate. So my x coordinate is negative 4, and my y coordinate is negative 2. So after I've graphed it, my solution to this systems of equations, the place where both lines cross, is negative 4, negative 2. I'm going to do another example. So let's look at number 3. Okay, we're just going to graph these. So we'll go ahead and start with the y-intercept on the first one. It's negative 4. So we put a dot on negative 4. The slope is negative 5/4, so that could be negative 5 over positive 4, or it could be positive 5 over negative 4. Okay, since I'm almost all the way down here at the bottom, I don't want to count 5 down on the y-axis because that would be way off the graph. So I'm going to go with this second one. I'm going to graph 5 up and then 4 to the negative side. And if we keep going again, so we count again, 1, 2, 3, 4, 5, it's off the graph. So I'm only going to put the 2 dots on this one because anything else would be off the graph. Okay, and then we have x equals negative 4. Remember, if something says x equals, that means it has an x-intercept of negative 4, and it has an undefined slope. There's no y-intercept if it says x equals. So I have to go to the x-axis and go to negative 4 And then an undefined line is going to go straight up and down. So the place that my two lines cross is right here on this dot. And if we write that as a coordinate pair, that's -4 on the x-axis and 1 on the y-axis.